guys, so let's do some tangent lines. So the first question is, find the equation of the tangent line of y equals 6x minus 5 quantity to the fourth power at x equals 1. So I'm going to let you in on a little secret. A lot of calculus professors like to use the directions write the equation of the tangent line, but basically if the problem gets higher and higher, like using chain rule, using product rule, using quotient rule, they like x equals 1. It's very easy to do. Because let's face it, you could do x equals 12, x equals 17, x equals negative 45, and you're going to get a really steep curve. So they like easy problems. So first things first, in order to do this, I needed to use algebra. I need a point, I need a slope, and then I'm going to make a linear equation out of that. So first things first, you plug in x equals 1 into the original problem. So if I plug in f of 1, that means 6 times x minus 5, where x is equal to 1. 6 times 1 is 6. 6 minus 5 is 1. And so therefore I've got 1 to the fourth power, or just 1. Therefore, the point that I'm going to use is 1 comma 1. Now I need to figure out the slope. Hey, there's no slope in algebra for this problem, but there is a slope in calculus for this problem. It's called the derivative. Notice that if this is f of x is equal to 6x minus 5 quantity to the fourth power, I'm not going to use power rule. Well, not entirely. I need to use the chain rule. The chain rule states that if I have a function taken to another power, or rather a function inside of a function, then I'm going to call this green. Let's just call this a bookmark for now. Green to the fourth power. So what this means is the derivative of green to the fourth power with respect to x becomes 4 green to the third power times green prime. So now I'm going to plug in the pieces. 4 green cubed green prime. Remember that the green is 6x minus 5 quantity cubed. And then I'm going to take the derivative of 6x minus 5. Just to refresh my memory, right? That's what the chain rule is. You don't have to do this step by step if you know how to master this already. Sorry, let me make that parenthesis a little bit neater. So now I've got 4 times 6x minus 5 quantity cubed. And then the derivative of 6x is 6. And the derivative of negative 5 is 0. And can I clean this up? Yeah, a little bit. Let me just make this a little bit easier for me. 6 times 4 is 24. So therefore, the derivative, if you really want it easy to plug in for x, 24 times 6x minus 5 quantity cubed. That's when I would say, hey, clean it up. It only takes 2 seconds, 4 times 6. So that's the equation of f prime of x. But what do I care about? I care about the slope when x is equal to 1. Hey, you see why now. So now I'm going to do f prime of 1, which means 24 times 6 times the input minus 5, and that all gets quantity to the third power. So let's figure out what f prime of 1 is. Well, now that I've got 24 on the outside, 6 times 1 is 6, 6 minus 5 is 1. 1 to the third power is 1. So just to save time, 24 times 1 is 24. So what this means is, at the point 1 comma 1, the slope at x equals 1 is 24. So that is my point, x1, y1. That is my slope, m. Here we go. Point slope to slope int now. So here's the equation from point slope to slope int. Y minus y1 equals mx minus x1. And now I'm going to plug in the respective red pieces. The y1 is, well, exciting, 1. The m is very steep, 24 in fact. 24 over 1, that's a very, oof. And then x1 is 1. Are there any double negatives I need to clean up? Well, no. So now that there's no double negatives to clean up, I'm going to distribute the slope, giving me y minus 1 is equal to 24x. 24 times negative 1 is negative 24. And now I want to get y isolated by adding 1 to both sides. So now I've got y equals 24x. Negative 24 plus 1 is negative 23. And that is the equation of my tangent line. So now I'm going to take a look at the graph y equals 6x minus 6x minus 5 quantity to the fourth power. I made it this blue dotted graph. Notice how very thin it is, right? Even if I zoom in a little bit. And I care about the equation, the linear equation y equals 24x minus 23. And let's see if it touches the graph at 1, 1. Sorry, where are you? 1. So 1, 1. So it should touch this graph right here and have a really steep slope, as you can tell. This part right here is going to be really steep. It's going to touch it right there. Boom! Oh, beauty. See how the red touches 1, 1 with a steep slope? So at that moment, the velocity is 24 over 1. Every one step to the right, it goes up 24 units. Every one step to the left, it goes down 24 units. All right, that's awesome. All right, so let me clear that. And let's move on to the next one. F of x is equal to x over x minus 1. Let's figure out what the x value they want us to do. So find the equation of the tangent line for f of x is equal to x over x minus 1 at x equals 2. Find the equation of the tangent line. Well, all right, I need to figure out what the point is first. So I'm going to plug in f of 2. So that means x over x minus 1, where x is 2. All right, not too bad, not too bad. So the top part is 2, and the bottom one is 2 minus 1, or 1. So f of 2 is equal to 2. Another exciting one. So the point is x equals 2, y equals 2. So that is going to be the x1, y1 of my curve. Sorry, the x1, y1 of my point, which is on this curve. Okay, well, how do I find the slope? Well, in calculus, we need to find the derivative. Take a deep breath. How do I find f prime of x for this particular function? Well, we have a function over another function. In other words, we're going to use the quotient rule, where the x is my u and the x minus 1 is my v. I got to do the quotient rule. So let's lay out our pieces. U is equal to x. V is equal to x minus 1. Okay, not too bad. So u prime, the derivative of x with respect to x is 1. And v prime, x minus 1. So the derivative of x is 1. And the derivative of negative 1 is 0. Oh, okay, well, at least it wasn't too bad. You notice I picked a quotient rule problem where the u, the v, the u prime, and the v prime are all manageable. So remind me again, what is the quotient rule? Recall that the quotient rule is the numerator is going to be u prime v minus u v prime over v squared. So the numerator, the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator, all that over the denominator squared. So let's plug them in. Okay, so u prime is 1. Not too bad, not too bad. V is x minus 1. Okay, still not too bad. Minus u, which is x, times v prime, which is 1. Okay, I can work with this. Over v squared, which is x minus 1 quantity squared. So let me just clean this up a little bit. So 1 times anything is just going to be itself. So let me just do x minus 1. Negative x times 1, that's going to be make negative x over x minus 1 quantity squared. Cleaning up the top, I can combine the x and the negative x, so why don't I just circle these bad boys, and cancel them out, leaving me with the derivative being negative 1 over x minus 1 quantity squared. So that is my f prime of x. Now comes the easy-ish part. I want to figure out what the slope is at x equals 2. So let's plug it in. F prime of 2 for negative 1 over x minus 1 quantity squared. I'm just getting a little bit ahead. All right, so let's plug in x equals 2. So the slope when x is equal to 2 is negative 1 over 2 minus 1 quantity squared. Oh, thank goodness. So 2 minus 1 quantity squared, that's going to be 1 squared, or negative 1 over 1, which is negative 1. So what does this all mean? The slope at x equals 2 is negative 1. So therefore, I just go back to algebra. It is calculus, but, I mean, it is algebra, but you see what the calculus can do. Now, we've got a point, we've got a slope, we go into point slope. Y minus y1 is equal to mx minus x1. So now, looking at my point, my y1 is 2, my m is negative 1, and my x1 is 2. Are there any double negatives for the y minus y1 or the x minus x1? Oh, thank goodness. Okay, so now I'm going to distribute the slope, leaving me with y minus 2 is equal to negative 1 times x, or negative 1x, that's fine. Negative 1x or negative x is fine, either way. Negative 1 times negative 2 is positive 2. And now I want to get y isolated. So that means I'm going to add 2 to both sides. The negative 2 and the plus 2 cancel each other out, leaving me with a tangent line of, you can put negative x plus 4. I'm not going to get mad if you put the negative 1 there. In fact, you know, if I were to go back in high school or go back in college, I find it easier for me to put it as negative 1x. But if you want to leave it as negative x, I'm not going to get mad. So that is the tangent line. Y equals negative 1x plus 4. So I'm going to look at the graph for y equals x over x minus 1. Look at that. We've got a vertical asymptote at x equals 1. No surprise. You remember the limits. So I care about not when x is equal to 1, when x is equal to 2. So notice that when x is equal to 2, let me get it right there. Come on, come on. There we go. When x is equal to 2, y is equal to 2. Hopefully the equation of our tangent line, negative 1x plus 4, touches the graph at 2, 2 in the direction of where it's going at that time. Boom! Ah, see, it never gets old. This really never gets old for me. This is awesome. So at this point of the curve, the slope is going down 1, right 1, down 1, right 1. But remember, the change is different everywhere on this curve, and that's what I want you guys to understand. Okay, moving on to problem number 3 now. Okay. Sorry, I put the papers all the way over there. Yes, I know, nice socks, nice America socks. All right, number 3. F of x is equal to x squared plus 3x minus 1 over, times 2 minus x. And once again, hard problem to take the derivative of, x is equal to 1. Okay, find the slope at x equals 1, and then write the linear equation of the tangent line. So first things first, well, it's easy for me to calculate the point, because all it is plug in x equals 1. So I'm going to go into the equation, blank squared plus 3 blank minus 1 times 2 minus blank. Thankfully, we've got a positive number, so I'm going to plug in x equals 1. Now, let's do some algebra. 1 squared is 1. Positive 3 times 1 is positive 3 minus 1 times 2 minus 1, which is 1. So 1 plus 3 is 4, minus 1 again is back to 3. 3 times 1 is 3. So what that means is when x is equal to 1, y is equal to 3. So that's my point, 1 comma 3, or my x1, y1 for the linear equation. Now, I want to figure out what the slope is. And in calculus, the slope is the derivative, the instantaneous rate of change. So recall that that f of x is equal to x squared plus 3x minus 1 times 2 minus x. And I want to figure out f prime of x. Go back a couple chapters. Go back a few tests. How do I figure out f prime of x? I've got a function times another function. I have to do the product rule, where x squared plus 3x minus 1 is my u, and 2 minus x is going to be my v, and this screams product rule. Now, theoretically, you could FOIL this out and combine like terms and do power rule, but I'd rather do product rule. It saves me a lot of time. So my u is x squared plus 3x minus 1, and my v is 2 minus x. So my u prime, the derivative of x squared is 2x. The derivative of positive 3x is positive 3. And the derivative of negative 1 is just 0. Now moving on to my v prime, the derivative of 2 is 0. Okay. The derivative of negative x is negative 1. So this is 0 minus 1, or as you guys know, it's negative 1. Okay, so now let's do the product rule. Well, if you recall the product rule, the derivative of a product function is u prime v plus u v prime. Nothing fancier than that. Okay, so now I'm going to plug in my pieces. U prime is 2x plus 3. My v is 2 minus x plus u, which is x squared plus 3x minus 1. And I just made it in time. My v prime is negative 1. Not negative 10. That's negative 1. But the point is, well, I mean, I suppose I could clean this up maybe a little bit, but you know what? That's not the goal of calculus. The goal is to plug in any x value into this complex derivative and get f prime of 1. I want to figure out the slope at x equals 1. See what I mean? It's a matter of picking your battles. When is it easier to simplify? When is it not so easy to simplify? And this is me when I throw in the towel. Just here, x equals 1. Shush. That's all. So 2 minus blank plus blank squared plus 3 blank minus 1 times negative 1. Come on, you. There you go. So I'm going to plug in x equals 1. And then I'm not going to squish everything in one place. So that means, all right, 2 times 1 is 2. 2 plus 3 is 5. 2 minus 1 is 1. Plus, okay, let me just do this quickly. 1 squared is 1. Well, 1 plus 3 minus 1, well, that is just 3. Times negative 1 is, there we go. So now I'm just going to jump to 5 minus 3, because 5 times 1 is 5. 3 times negative 1 is negative 3. So 5 minus 3 is 2. So all that work, the slope for this product function at x equals 1 is 2. Oh, well, that's not too bad at all. Go back to algebra. I've got a point, I've got a slope. Let's write the equation and convert it into slope int. So I've got y, let me actually go over here. Y minus y1 equals mx minus x1. So now I'm going to plug in. M is 2. Oh, I should probably go in order. Y1 is 3. M is 2. And X1 is 1. Are there any double negatives I need to clean up before I move on? Nah. So now I'm going to distribute the 2. Y minus 3 is equal to 2 times x, which is 2x. 2 times negative 1 is negative 2. Okay, and now I'm going to get the y isolated by adding 3 to both sides of the equation. So then y is equal to 2x plus 1, and that is the equation of my tangent line. So notice that I'm going to plug in the tangent line to Desmos, 2x, so 2x plus 1. And I'm going to look at this product function. Let's take a look at it. I don't know what it looks like. And that's the beauty of calculus is you can just look, you can figure out the equation and figure out what its slope is regardless of what it looks like. Oh, man. So you see how it bends a little bit? It goes down, it goes up, it goes down again. I could not have predicted that. But if I say I want to figure out what the slope is at x equals 1. 1, where are you? There you are, 1 comma 3. Come on, get closer. There we go, 1 comma 3. You notice that it's still a positive slope. Specifically, the slope is going to be at positive, slope of up to right. Oh, look at that. It never gets old. It never gets old. This is awesome. Yeah, so that's the equation of the tangent line at x equals 1, y equals 3. Love it. Okay, just to make sure, let's do 2 more problems. Okay, another one. F of x is equal to 5x squared minus 2 times x minus 4x squared. And I want to figure out the slope once again. Surprise, surprise, your calculus teacher is smart but lazy. So find the equation of the tangent line at x equals 1. Well, first things first, we need a point. So in other words, I need to do the point. Well, I should have written f of 1, but you get the idea. F of 1. Which means I plug in x equals 1 for every input of the function. All right, 5 times 1 squared, well, just to be thorough, 5 times 1. And then I've got 1 minus 4 times 1 squared, which is 1. So 5 times 1 is 5. 1 minus 4 times 1, which is 4. So 5 minus 2 is 3, and 1 minus 4 is negative 3. So therefore, when x is equal to 1, y is equal to negative 9. Therefore, the point on this curve at x equals 1 is located at x equals 1, y equals negative 9. And that is our x1, y1. Now, oh boy, looking at this function, I want to find the derivative with respect to x. You guessed it, I got to do the product rule. Or, you could FOIL it out and combine like terms and do power rule. That's your choice. I personally like the product rule because I don't feel like doing that. So let's do the product rule, where 5x squared minus 2 is my u, and x minus 4x squared is my v. So let's label out our u and v. And v, there you go. So my u prime is going to be, well, the derivative of 5x squared with respect to x is going to be 10x. and the derivative of negative 2 is going to be 0. So then v prime. All right, the derivative of x with respect to x is 1, and the derivative of negative 4x squared is negative 8x. So my u prime is 10x, and my v prime is 1 minus 8x. Well, now let's just do the product rule. Make life easy. Recall that the product rule goes u prime v plus u v prime. So u prime is 10x, v is x minus 4x squared, and plus u, which is 5x squared minus 2, and v prime, which is 1 minus 8x. There's no hole in the binder paper like last time. Okay, so now I could distribute the 10x and FOIL. You know what? That's not the goal. The goal is I should be able to plug in the slope for a given x value, in this case x equals 1, and just figure out what the slope is. I don't need to simplify right now. So I'm going to plug in x equals 1 everywhere on this. Okay, so let's do that. So now I'm going to do f prime of 1. So that's 10 times 1. Sorry about that. Let me put the x, because I'm not too much of a perfectionist, but I am there. I just want to make sure that you're clear. You're finding out the slope at x equals 1. So that'd be 1 minus 4 times 1 squared plus 5 times 1 squared minus 2 times 1 minus 8 times x, which is 1. So now that we've plugged in x equals 1 for every single part of this function, piece by piece, I'm going to evaluate it. 10 times 1 is 10. I'm going to leave that alone. Okay, 1 minus 4 times 1 squared. Well, that's just 1 minus 4. Plus 5 times 1 squared, that's just 5. So 5 minus 2. And then 1 minus 8. So let's just do this in steps. So 10 times negative 3 plus 3 times negative 7. Oh, this isn't going to be too bad. Oh, I take it back. So 10 times negative 3 is negative 30. And then plus 3 times negative 7, negative 21. So I'm hoping that this is correct. I checked it before. It is correct. But you see how even x equals 1 can give me a headache. So when x equals 1, the slope at x equals 1 is negative 51. So the slope is negative 51. Lovely. Wow, that's pretty steep downward. All right, so let's go to y. Wow. Y minus y1 is equal to m x minus x1, and plug in these 3 inputs. I care about the y coordinate of my point, I care about the slope, I care about the x coordinate of my point. So let's get going. Y minus negative 9, okay, here we go, I see you, equals negative 51, x minus x1, which is 1. Are there any double negatives in my point-slope form? Y minus negative 9 can be converted to y plus 9. So now I've got negative 51, x minus 1. We're good. So now I'm going to distribute the negative 51. So I've got negative 51x plus 51. Negative 51 times negative 1 is positive 51. And now I've got y plus 9. So now I want to get y isolated by subtracting 9 from both sides. Well, y equals negative 51x. And if 51 minus 10 is 41, then 51 minus 9 would be plus 42. So that is the equation of my tangent line. Let's verify with the graph, as insane as it may look. 51x plus 42. Jeez Louise. Okay, so let's take a look at this graph. For x squared plus, wrong one. This graph, yeah. So even though it's funky looking, I care about the point 1 comma negative 9. So let me just scroll down a little bit. Whew. Yeah, no wonder the slope has a slope, the graph has a slope of negative 51. So if I take a look at 1 comma negative 9, ooh, that is a downward slope. Let's see if it touches the curve. Boom. Remove it just to see. Yep, that is a very steep curve. Good heavens. Yep, that is the tangent line. I wish I could say like that's poetry. I'm like that's scary. I do not want to go skiing on that slope. Okay, last one, and then we'll call it a day. Okay. Write the equation of the tangent line, but this time it's a cubic function. So no product rule, no quotient rule, no chain rule. So let's figure out the equation of the tangent line at x equals 2, just to give it a little bit of variety. Well, first things first, I need a point. So when x is equal to 2, I plug in every input has 2. So 2 cubed is 8. 2 squared is 4 minus 2 and plus 3. Negative 3 times positive 4 now is going to be negative 12 minus 2 plus 3. So let's take this in pieces. 8 minus 12 is negative 4. Negative 4 minus 2 is negative 6. And then negative 6 plus 3 is negative 3. So therefore, the point at x equals 2 is y equals negative 3. So that's going to be my x1, y1. So far, so good. I'm happy. I like small numbers, certainly better than negative 51. And now, this should be a breath of fresh air. How do I find the slope of a power function? What rule do you think I need to do the power function derivative? I'm going to take the power rule. The derivative of x cubed is going to be 3x squared. The derivative of negative 3x squared is going to be negative 6x. And the derivative of negative x is negative 1. And the derivative of 3 goes away. Now that I figured out what the slope is for any point on the curve, well, let's figure out the slope at x equals 2. Let me just space it out a little bit. Okay. So I'm going to plug in 3 times x squared minus 6 times x minus 1, but every x is x equals 2. So now let's put this together. 3 times 4 minus 12 minus 1. So that is 12 minus 12 minus 1. 12 minus 12 is 0, minus 1 is, hey, the slope is negative 1. So if I've got a point, 2 comma negative 3, where the slope is negative 1, thank goodness, certainly better than negative 51, now I'm going to go into point slope into slope int. So now let's plug in where y1 is negative 3, m is negative 1, thank goodness, and x1 is 2. Are there any double negatives I can correct before I move on? Yeah, this y minus negative 3, I can convert that into y plus 3 is equal to negative 1, x minus 2. So let's distribute now that we ain't got no time for no double negatives. Y plus 3 is equal to negative 1 times x, or negative x, or negative 1x. I prefer it that way, even though public school would prefer it as negative x. Negative 1 times negative 2 is positive 2. And now I want to get y isolated by subtracting 3 from both sides. So if I subtract 3 from both sides, the equation of my tangent line becomes y equals negative 1x. 2 minus 3 is negative 1. Ah, that's a breath of fresh air. So let's plug in the slope y equals negative 1x minus 1 and compare that to the cubic function. All right, let me just go back home. And let's plug in, what does this x cubed graph look like? Let me make it dotted just so we can see the tangent line a little bit clearer. So this is the curve, x cubed minus 3x squared minus x plus 3. And I care about when x is equal to 2 and y is equal to negative 3. If it'll let me go there. Yeah, it won't let me go there, but there is a point 2 comma negative 3. If I zoom in close enough. It's not letting me go there. But the point is, if I plug in the tangent line, see, that is poetry to me. Certainly not negative 51 as a slope. But yeah, it touches the curve, and it says at that particular point, zoom in close enough, at 2 comma negative 3, the slope is negative 1. And where does it touch the curve? At 2 comma negative 3. Whew. We're going to have one more day of this, and then we're going to have a test on Monday. And I promise I'll keep it basic. I'm not going to make it, I'd rather you understand the process than try to do the hardest problems humanly possible. Okay? Have a good day, guys.